Hi. Exam 1 review. I know. Depressing, right? So, in your infinite wisdom, you picked to have exam this weekend. So, that's going to be. Why is this pink now? Get out of here. Exam 1 on 10/9, 10/10, and 10/11. So, Friday, Saturday, Sunday. All day through the night, and then closes at midnight, right? Minute before midnight, actually, 11:59 p.m. on Sunday. You can take the exam at any time in between, right? The available dates. And, with a little bit of common sense, you would know that your 91-minute exam, as you requested, is going to end. If you start 10 minutes before midnight, you only have 9 minutes, right? And then it will shut down. So make sure that you start at least 10 p.m. on Sunday. That's the latest that you can push it for. I would obviously not suggest that, but then for some reason you might want to. Put notifications in your phones. Now, exam 1 is on Canvas. On Canvas. So you do have sample tests on MyMATLAB, but those are sample tests. They do not count towards your grade. You have to do the exam that is posted in Canvas in assignments. So you go Canvas, you go in assignments, and when you start the exam, it will start ticking those 91 minutes down. And so that's that. It's on Canvas. So anywhere 10 to 12 problems, whatever. Some of them will have parts. Obviously, you do not have time to look up problems and things because, given that the exam is all online and all of that stuff, there are more problems than there are usually in class where you can't cheat that easily. You can still cheat, I know that, but I mean, I see it all the time. But the thing is that right now, you are told not to use graphing calculator, right? That's one thing. The other thing is you should not be using any reference, no notes. And the only thing that I can do is to say that, if you don't learn Calc 1 and you have to go to Calc 2, you're just doomed. It's as simple as that. That course is absolutely insane, and without knowledge of Calc 1, you'll find yourself learning Calc 2 concepts and then relearning Calc 1 and trig at the same time, and then just good luck. I never seen a student with C in Calc 1 pass Calc 2, yet alone someone who cheated in Calc 1 learned nothing and then attempted Calc 2. I mean, I'd be amazed if you lasted like a week. That would be amazing. But yeah, anyway. So what is going on with this exam? We have chapters 1 and chapter 2. Chapters 1 plus 2. And chapter 1 was not taught in class, right? Chapter 1 is something that you guys studied before. I did go over it on a day 1 briefly through many of those concepts from pre-calculus, definition of a function, which is one of the questions on the test. Obviously, I told you that many times. And, all other concepts like graphing and shifting functions, composition of the functions, domain, range, what else was there? Inverse functions. So all of those things that are in chapter 1, right? They are all something that we use in calculus. Many of those things frequently. I mean, function. Every single problem has it. So we need all of that knowledge, but even though it's very important, that's all not calculus. It's all pre-calculus in chapter 1. So it's about 30% in chapter 1 and about 70% in chapter 2, which is on limits. So from chapter 1, you have your definition of a function. You have, what else did I say? Graphing plus shifts. Let's go with the domain and range. Function composition. Inverse function. Inverse of a function. I think that's it. Definition of a function. Yeah. Chapter 2. Limits. Now remember what are all the ways that you can take the limits. We started with the graph with a red and blue arrow, Romeo and Juliet. Then we went into a chart. Still used red and blue to show that motion through numbers. Then we went into plug-in. Then we went into algebra. Then we went into squeeze. Right, there was the squeeze theorem. What else was there? And then all of this, right, we had one-sided limits with that very important theorem, which states that overall limit exists if left and right limits are the same. Because limit from the left and limit from the right, they always exist. No matter what, they always give you some value or infinity. So you cannot have does not exist on one-sided limit. So it's either a number or it's infinity. Now, when you get something on a one-sided limit from left and from right, then if those two numbers are the same, overall limit exists, then it's that number. And if the numbers are different, then limit does not exist. So that was a jump. Now, for some reason, a lot of students do not learn this most important theorem of chapter 2, and then they wonder why they don't understand limits. It is impossible to understand anything in limits if you don't know that limit x goes a minus of f of x needs to be the same as the limit x goes a plus f of x equals L, then the overall limit x goes to a from both sides at the same time is that L. Otherwise, limit does not exist. This theorem here is the way you solve limits in calculus and differential equations and everywhere else. If this is not clear as day, you still know nothing about limits. All of that knowledge that you can factor and cancel, and that's all meaningless. All of it, right? If you don't understand what this means, if you don't understand this notation, if you don't understand this if-then situation with otherwise at the end, then the entire chapter 2 for you is non-existent. This is the core of everything in chapter 2. And this is the theorem that gives you the way to solve problems. As soon as you see the limit, you say, oh, okay, is my left limit and right limit the same? That is the natural response, like when you see something and you say, oh, this is food, this is not food, right? You see an eraser and you say, that's not food. That split second of that's not food in your head is the same thing when you see a limit problem you know that you need to use this. That's it. So it should be like a reflex response to use this, because that is the way you solve limits, and there is nothing else that you really need to know other than this. But then we did add vertical asymptotes, horizontal asymptotes with their formulas, right? So the vertical asymptote was the limit x goes to c of f of x needs to be one of the infinities, or you can also have those side limits there. Horizontal asymptote, so these are definitions, right? You can go to positive or negative infinity to give you a finite value. So if this is true, then vertical asymptote at x equals c, and if this is true, then horizontal asymptote at y equals L. You can see L where it comes from, right? It's the answer of the limit. You can see C is right here, right? X goes to C. So those are the values that are already in the formula. And if these formulas hold, then your asymptotes are at C or L, depending which one you're looking for. It's the entire calculus becomes clear only when you learn the basic theorems and definitions. And if you don't know them, your best chance of passing Calc 1 is to try and mimic solutions to problems without any understanding, and you might pass. You might pass Calc 1, but then you're done. It's just, there's no way that you can move on because Calc 2 is using all of this stuff a lot. And you really don't have time to relearn the entire Calc 1, so you can barely perform in Calc 2 when you're taking Calc 2, obviously. So you have your limits, and then you have your asymptotes, and then you have your continuity. And we said that's going to be at a point. Those are the three rules. Then we have those three graphs to break continuity, which is discontinuity. And if you spend time studying those graphs, you see visually what it means for a function to be discontinuous. Now, if you, after that one, if you went and just did your 5 problems for homework and closed the books and said, yep, I'm good, you are nowhere close to being good. If you haven't spent 30 minutes staring at those 3 pictures that I had, right? There was one was like that, one was like just a hole, and another one was with a hole that was dislocated. Like if you haven't sat down and stared at this for like 30 minutes and tried to understand, put together the Romeo and Juliet, right? Juliet is approaching the value from the left, approaching value from the left, approaching value from the left. So she's moving on this line constantly over here. And then Romeo from the other side, moving on this line, moving this way, moving that way. Understanding that the limit will pass on these 2 pictures, but it will fail here because it fails this, right? It fails this stuff. It's all connected. All of it. All of it is connected. And you have to sort these things in your head. You have to sort this stuff in your head, and then you have to make sure, right, to understand how these things fit together. And only then you actually have the knowledge of calculus and you can solve any problem in the book. If you don't do these things, if you're not used to studying before doing the homework, your homework is not a study time. Homework is practice. Study is when you learn. I hate to bring up the driving test, but you should have first, read the book and learn what each sign means, right? And, what is the meaning of the stop sign? What is the meaning of the red light, right? You need to know the theory, and then you go and you practice driving, right? Now, the fact that you see other people drive for, 15 years before you pick up and drive, those things that you should have learned from the book, you learned because you've seen other people drive. But there is a whole book with theory on driving, right? The first step of going anywhere is to walk around your car once to make sure that all of your tires are fine and that you still have all of your, your headlights and stoplights and all that stuff. Because if you just approach your car on the side and someone jacked your tires on the other side, what do you think is going to happen when you start driving, right? And you have no tires on one side of the car. So these are the things that you have to understand. The calculus is unforgiving in that respect. If you don't know these things, the red and the blue stuff, the whole thing falls apart very quickly, because you might try to go and make the argument that you have never seen a problem like that before, which is irrelevant, because if you know these solve all types of all problems that exist in calculus. And that's technically what it is. So, oh, and we have one more thing I forgot. The precise definition of limit, right? Remember that one? Plus 2 pictures, graphs. Let's put graphs. That explain limit, and limit does not exist. So this is the stuff that it's on the exam. Question ask, write the formula for blah, 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 or write the definition for whatever function, right? Knowing those things, and then obviously problems in which you have to use those things, especially using these red and blue formulas. Then you have also your 3 rules. Oh, let's not forget those global. You remember that you have those the global continuity, 2 theorems, which you use to solve problems to show that something is continuous on its domain, right? So you use those. So I think this covers everything that shows up on the test. The pre-calculus has the, some also the specific stuff that you guys have seen in your pre-calculus courses that we didn't go over, particularly trig, but we are getting into trig after the test, actually, when we do derivatives of trigonometric functions later on in the chapter, inverse trigonometric functions, and then we start using trig to set up some word problems. Right now we don't have a lot of trig past maybe take a limit of a trig function or something by maybe plugging in or factoring through a double angle identity or something basic. Nothing special, for trig on the first test, and then the trig kind of starts making its way in until it makes the atomic bang in in Calc 2, where you get trigonometric integration and trigonometric substitution, and entire chapter 12 is just trig. So yeah, it will come back strong in Calc 2. We don't have too much trig here. So 91 minutes. It will start. The timer will start from the second you open up the exam. It has to be done in one sitting. That was also another question that someone had. So you cannot save it and then come back 5 hours later or the next day and then continue, because obviously you have seen the test, and then you can spend 5-6 hours solving it, and then you can log back on, right? So to prevent that type of cheating, you have to do the exam in one sitting, just like you would do it in classroom, right? So you sit down, you do the test, and then within 5 minutes of closing the exam, you have to email me your work, otherwise it will not count. That's the school rule. So here I'll write in blood 5min to send in pictures or scans of your exam 1 work. All right. Make sure that you are sending in your exam 1 work. Obviously, don't send me the recipe for a dish or something, because I'm all good. I can cook pretty well. Make sure you are sending the work for Calculus 1, for exam 1, for the exam you just took. You can take pictures with your cell phone. Don't give me the excuse like one student tried to make the excuse, right, after obviously cheating in certain ways, that the camera on the phone is broken and, you know, he couldn't take the pictures. Oh, really? Which phone has only one camera? Yeah, probably old iPhone or something, but phones now have 3 cameras. You have the front camera, the 2 cameras in the back. And then in addition to that, there are other people with phones around you. So if your phone exploded or ran out of battery or something, then take someone else's phone and take the pictures. I can only consider emails that I received within 5 minutes of you submitting the exam. So if you have your pictures or scans of the stuff sent in later than that, I cannot consider them for your partial credit. And that will be it. Now, you know, for some graphing questions, where the only thing you can do is answer it on paper and take a picture and send it in. If you haven't sent it, that the question is 0, right? Because there's nothing, right? So type in answer only. That's for Canvas. Then email work. So if your answer is, let's say, x equals 1/2, that's the only thing you type in Canvas, x equals 1/2. And then your work will be in your email to me. And then if that half is wrong, I will know exactly what partial credit you have, because I know what you did and I know what's wrong. Now, if you don't send the work, obviously it's 0 points, because there is nothing to talk about, right? There is no work, and the answer is wrong. So there is literally nothing, which is common sense is going to be 0. I think that's it. Do you have any questions, whether it's procedure, policies, or any particular calculus problems from homework or something that we could work through as the part of this review? You have to unmute yourself if anyone is trying to talk now.
Actually, I have a question.
Mm-hmm.
So you said there's a sample test on My Math Lab.
Yes.
Is that like, I don't know if you can answer this, but is that similar to your type of questions, or yours like a little different?
I have no clue what the sample test, but it's all Calculus1. So
Okay.
if you know the theorems, definitions, you understand concepts, then you really don't care, right?
Okay.
If you are trying to look for similar problems, then you're definitely not going to do well. Those are the two truths about calculus. So what we refer to monkey sees, monkey do, which is, you know, learning algebra. All of the problems are similar. You just change numbers. But we have seen the difference, right? If we go just to that difference quotient limit, where you have the limit age goes to 0, this is in 2.3. Limit age goes to 0, or f of x plus age minus f of x divided by age, which we learned that that's actually the derivative in 3.1, but the calculations and procedures are in 2.3. So this one, right, we did for x squared, maybe x squared plus 3x minus 1, then maybe 5 over x. But how about square root of 3 minus x? We can do that, right? So the idea is that if you just memorize the steps for x squared, you might be able to, probably not, but might be able to do this one. But then for these two, you're just gone, right? So that's the thing about the similar exercises. Now, the sample test is great because you get to take the sample test and it grades you immediately. It tells you at the end of the test how much you scored. And then you say, okay, what did I get wrong? And you still have time. So if you do the test today, that will be the best. So on my MATLAB, go to assignments and change homework to quizzes and tests. And just scroll down, it will be a section that says sample tests. And you can retake that exam as many times as you want. That grade does not record anywhere, so you can practice as much as you want. Okay?
Perfect. Thank you. Appreciate it.
You're welcome. And also, guys, your homework, for most of your homework, it's closed now. You cannot access it. For extra practice, you go to study plan, because study plan contains all of the problems, including your homework, and it's open 24/7 for Calc 1, 2, and 3. Like if you want to go in and you know, practice chapter 16 from Calc 3, you can do that now because it's open, okay? So with my MATLAB account, that study plan has access to all of the problems for the entire Calc 1, 2, and 3, and it's open 24/7, no due dates or anything like that. So you can practice there, but I would definitely suggest you do the sample tests to see where you stand. Again, if you're not using this stuff to solve problems, then you are approaching in a wrong way. You are not doing well with concepts, and you should study and figure that stuff out before you attempt solving problems, because this is the way to solve problems. What else? Any questions? Any problems?
Can you just do a quick review on the squeeze theorem again?
Oh yes, that was the one when you have what I called in quotes bad behaving function, right, which did right something like this, and then there was a function on top and a function on the bottom which met at the point of interest. So the in the nutshell, right, the theorem goes like this: if you have a function squeezed in between two functions like this, then their limits are also squeezed. Limit x goes to whatever value a of f of x would squeeze the limit x goes to a of g of x would squeeze over the limit of age of x, where if limit of f of x is the same as the limit of age of x, so those are the two outer limits, then the one in between is squeezed inside and has to have the same value, right? So then the limit of the function we are looking at is L. So this is your, let's say, f, this is your g, this is your age of x. So, and this over here would be the value x equals a that your limit goes to. So you can see that this badly behaving function in the middle, which I don't know what the limit is, and I can't use the graph because it oscillates too quickly, and I can't use the numbers because the numbers oscillate also too quickly. So all I can do is construct two functions and then make sure that those two functions are squeezing the function in between. Therefore, right, because you have a squeeze from the top and the bottom, you are going to have the limit of the whatever is squeezed in between to be the same as the two values on the other two functions. Does it make sense now?
Yeah. Like, what if the part that you're trying to like evaluate is at like a different x, that you would just move those two functions f and h to where the x is?
Well, you are constructing f and h. F and h are constructed when you look at G, you construct these two functions, f and h. And those two constructed functions should be the ones that are easy to compute. So when I talked about the concept, right, I believe we had like x squared sine or cosine, I don't remember, I don't care, sine of cosine of 1 over x. So we said we want the limit as x goes to 0. I think it was sine. I think it was sine here. Yeah, sine. So we want the limit as x goes to 0 for this. And then you said, okay, let me see, because I can't do 1 over 0 is infinity, sine of infinity. That's not a value. So I really can't do that. And then this becomes technically 0 times does not exist, right? So we can't solve it. But if we construct two functions, one above and one below of this function here, actually, without limit, if I am able to construct that, then that function is squeezed in between and we have the values. So you started with the good on idea that sine of 1 over x is bounded by 1, meaning that the range is at most 1 and at minimum -1. So that means this, and oops, 1. And now when you multiply by x squared, you get negative x squared sine 1 over x, and then x squared. And now you see that your problem matches in the middle here. So you constructed the function. But when you look at the edges here, these are jokes to take the limit. So limit negative x squared was equal to 0. And the limit of positive x squared as x goes to 0 is 0. And look, this is exactly what our theorem said up there. When the two constructed for f and f and h, so when the two constructed functions give the same value, that's this part, when the two constructed functions give the same value, then that value becomes the answer of the limit of the problem you are talking about. So these two together tell us that the limit of x squared sine 1 over x is 0, because it is squeezed in between two zeros. Right? You can't squeeze 10 in between 0 on the bottom and 0 on the top. That makes no sense. The
Yeah,
only
I see.
thing, right? So that's that. We will have later on in Calc 2 functions collapsing on other functions. Now you only have to compare one point, right? And in Calc 2, when we do power series, we are going to overlap the entire function. So you will be overlapping polynomial, let's say, onto a trig function. So it tends to be a little bit trickier there, right? So, investing extra time now is very smart.
Two functions on the same graph?
Yes, yes. and they have to all end up at the same point. You cannot have a function, one of those functions, f or h, right, the squeeze functions that you construct, you cannot have them away from your main line, right? Your main line is what counts. Cool?
Yeah.
Of course, right? It's calculus. If nothing, learn calculus just to troll other people. That would be the craziest reason to learn calculus. Like, why did you go to school? Why did you learn calculus? Just to troll. That reminds me of a guy who took differential equations with me when I was a student. He was a film major and he wanted to be director, taking differential equations just for fun. And when someone said, "Why? Are you insane?" he said, "Oh, that's when I do casting. I can ask them to solve the second order differential equation, and if they can't, then they can't get the part." And I said, "Dude, you'll never record a single movie with that attitude. Like, none of these people can add." But anyway, they can't add. You want them to solve second order differential equation? You will not have cast in that movie. Anyway, any other calculus questions? Problems, concepts?
I do have one more question.
Yep.
When you're taking a limit, and you go from both sides to a specific number,
Sure.
does that mean that limits are approximations? Or are they exact?
They're exact because you are looking at the trend of where they're going to, like the final destination. So they are not approximations because they're always collapsing onto a y value answer. So they're not right.
So could you say that it's almost infinitely close?
That's exactly what it means, which is what that 2.7 definition was when we said epsilon larger than 0, delta larger than 0, and these can be as small as possible, so that when you make that tube around your function, right? So this was your A, this was your L, and then you had epsilon and delta on either side. These deltas over here were infinitely small. So not approximated by 0.01, approximated by 0.000000, and then put infinitely many zeros and then go 001. You know what I mean?
Yeah. So then
these are
does that
insanely
mean,
small values.
yeah. So, but does that mean that then infinity is like a place to be at and therefore a constant?
You are getting into higher tiers of mathematics where there is something to that statement, but it's very touchy to talk about it in Calc 1 with the knowledge that it's currently available and on the table. There is mathematical projection that will allow you to project your positive infinity and your negative infinity onto a single point on a circle that is called the North Pole, let's say. It's called stereographic projection. So when you take a look at this, right, you would see that if this is your 0, and then you have your 1, 2, 3, 4, you see how the radius from here, it can project these numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 around the circle. So infinity will be projected there, and this infinity will be projected there. So both infinities merge into a same location place that you say is constant. But again, you have to sit there and study these things for much more than, right? Much more than Calc 1, only to kind of grasp those. But yes, there is something to your statement.
So now, if you did define infinity as a constant, then would the derivative be 0?
Unfortunately, no, derivative does not exist at that point, because even if you look at the stereographic projection, remember that you have two infinities coming into the same location and they don't agree on a sign, just like this puppy over here, when this is negative infinity and positive infinity for 1 over x, and then there is no limit, right? The best way to explain that you asked is also important for the upcoming exam 2, for instance, when the derivative doesn't exist for this guy, because coming from one end the slope is -1 and coming from the other end is +1. So at this point here you have two different derivatives. It's actually the limit that fails, because we had that picture before when the limit makes a jump like this. Then, right at this point, then Juliet walked up to this point. I'll put J for Juliet, and Romeo came up to this point, and they are infinitely far apart. Actually, they're right. So that's the thing, that there's no limit, because Juliet holds the ground that limit is 3, and Romeo holds the ground that limit is 6. So which one is it? Is it 3 or 6, right? And since they need to be equally represented, right, no one gets to win. So the consensus is limit does not exist, because you can't claim it's 3, you can't claim it's 6. So that will carry there. But again, we did this to show that limit does not exist at 0, because these infinities went apart. Now we had another problem that we did in class for limits at infinity, which is positive infinity going this way forever, and this function, let's say e to the negative x. We said that the limit of e to the negative x as x went to infinity was 0, because as you go infinitely far away, the values keep dropping and dropping and dropping and dropping. So at infinity, the value is 0. And that was the horizontal asymptote definition that we did. So horizontal asymptote at y equals 0. So that was that. Question from the YouTube saying, when you said we had 5 minutes to send in pictures, did you mean 5 minutes per question, or 5 minutes or 5 minutes after we finish? 5 minutes after you finish the exam. I have no clue how much time you spent per question. The Canvas will only tell me that you ended your exam at, let's say, 8:07 p.m. on Saturday, which means that your expiration time for the email is 8:12 p.m. on Saturday. So that's the 5 minutes to send. Now, usually when you do your exam, you might have like 3 to 5 pages of notes. So you should be able to do it in, less than 2 minutes, and that's even when, with emailing. But, we all agreed that 5 minutes, not you, the colleagues, that 5 minutes is just fine to send. So it's not per question. It is 5 minutes for after you're done with the test and you submit the test. Now, some students take pictures while they're taking the test, and then they just shoot the email from their phone with the photographs. I had students do the exam on their phone, because you can. The only thing you need to click is, let's say, x equals to 3, or the answer is 16, or, that type of stuff. You can comfortably type in those answers using your phone. And what they do is they embed the pictures. They do each problem on a separate piece of paper, and then they embed those pictures into the box within the test. Now, granted that I only have usually 3 people that do that, because it does require some technical competency to do that. and organizational, obviously, structure and care, you can do that as well. That's fine. In which case you don't have to email after. So your Canvas question goes like this, and then there is a box here to type your answer. So you can just type in x equals 6, and then you can just click the little picture icon and import the photo of work. Now that saves me opening an email, and I know that you did it while you were taking the test, so then the 5-minute rule doesn't even apply to you because you did that. But it's not required. I mean, it's just something that, you know, something cool that you can do. But sending emails is fine. And yeah, that's that. So that's that question for 5 minutes per. Can you imagine if you had 12 questions and 5 minutes for each one? So you waste an hour just on sending pictures. And then you have just 31 minutes to solve the whole test. That would be cool, huh? Anyway. All right, so anything else? Awkward silence. Going once, like on an auction. Going twice. And we're done for today then. Okay, fine. So we're done for today. I will have office hours soon. You have to switch the Zoom link. The link is in announcements on Canvas. If you have anything to ask in private or anything like that, sure. Join my office hours today at 5:30, tomorrow at 12 noon, midday. And then, yeah, follow the schedule. I'll be around. See you Wednesday. We continue our calc. Bye.
Thank you.